Flack math! Give me some math and I'll give you some flack. Flack math!
So let's just start with number 1. So find the zeros of this quadratic function. So finding the zeros mean just set it to 0. So I'm going to rewrite it like this. 0 equals 9x squared minus 49. Okay, and so we're going to solve this quadratic equation by factoring. So if you guys wrote down these steps, to solve, the first step is to factor, and then the steps to factoring. What's the first step of factoring? Well, it's see if there's any GCF. There is. You can take, there's not, sorry. There's not a GCF. There's nothing in common. 9 and 49 have nothing in common. The second step is to look for a difference of 2 squares. Well, we have that. So 9x squared is a square and 49 is a square. So how do you factor it? It's the square root of the first plus the square root of the second, and then times the square root of the first minus the square root of the second. It doesn't have to be in that order. You could subtract first, doesn't matter. Okay, then the last step to solving by factoring after you factor is to solve, put each parenthesis, set each parenthesis to 0, and then solve it. Okay, so 3x plus 7, this needs to be 0. Or this needs to be 0. 3x minus 7 equals 0. Okay, so solving, get rid of 7. So 3x equals negative 7. So basically x equals negative 7 thirds. Or if you solve it for x over here, you get 3x equals positive 7. So x equals positive 7 thirds. Okay, remember the shortcut. You can look up here and you do the opposite of this sign, and then the second term over the first term. So negative 7 over 3, positive 7 over 3. Okay, so these are the 2 zeros. So they kind of help you through that if you wanted to use these things, or sometimes these can be confusing. So just do it your own way. That's fine. Okay. So unless there's any questions with number 1, I'm going on to number 2. All right, I don't see any hands. So number 2, find AB and blah, blah, and blah, blah. Okay, so this is, we're gonna multiply. I'm gonna zoom in a little bit just so I can write a little. Smaller here. That doesn't help. Okay, I think my window is going to be in the way, but it's all right. So basically, first thing we're going to do is we're going to multiply this row times these 2 columns. Okay, so negative 2. So the first column, you remember it's negative 2 times negative 2 plus negative 2, or plus negative 2, oh wait, sorry, negative 3 plus times 2. Oh, I can't talk. Negative 3 times 2. So that's what goes in the first column, first row, first column. So that's 4 plus negative 6. And they give that first one to you. That was nice of them. That equals negative 2. All right, so that's a negative 2 there. Now I'm going to multiply negative 2 and negative 3 times negative 3 and positive 4. So then I get a 6, positive 6 plus negative 12. So that's negative 6. All right, so after that, we're going to move on to our second row that we're going to multiply by the same columns. So this negative 1 and 0 by these 2 things. I love having a 0 in there because really when you multiply by 0, it cancels it out. So you don't have to add anything. So this is just going to be positive 2 and positive 3, right? Because look, -1 times -2 is +2 plus 0 times 2, which is 0. So you're not adding anything to that +2. So -1 times -3 is +3 plus nothing is just +3. All right, then the last row, multiply the 3 and the 5 times both of these columns. So you get -6 plus 10 is a +4. And then a -9 plus 20 is +11. Is that what you guys got?
Yeah.
Okay, awesome. So if you have, I went through that first one up here, but and we've done stuff like this on past videos too. So look for matrix multiplication on the YouTube channel if you need more direction on this. Okay, next, I'm going to zoom out again. Find the determinant using the expansion of minors. Okay, I don't remember what that is, but what we're going to do is we're going to multiply. So basically we have to take this -7 and we're going to create a little matrix here. Oops. So the minor matrix of -7 is basically the -3, 4, and 0, 6, because you're kind of blocking out the row that -7's in and the column that -7's in. So you're going to multiply -7 times the determinant of this matrix, -3, 4, 0, and 6. Remember, the determinant is like these big absolute value signs, okay? All right, and then it's, I think it's subtracted, right? It's subtracted and then added. Oop, what happened? Okay, so I'm going to subtract the next row here, which is 3. So the determinant of this, or I'm going to change color so you can kind of see. So then we're going to subtract 3. And then the matrix of this guy is, if you ignore the row and the column that the 3 is in, it's going to be 5, 1, 4, and 6. So 5, 1, 4, and 6. All right, and then the last one, we're going to add this 2 here. And then with that minor matrix, so remember, you ignore the row and the column that the 2 is in. So you're always ignoring that first row. Ignore the 4 and 6. So you get a 5, -5, 1, -3, 0. 5, 1, -3, 0. So now you're just calculating the determinants. So it's -7 times -18 minus 0 is -18. Minus 3 times 30 minus 4 is 26. And then plus 2 times 0 minus -3 is a +3. All right, so let's do that math and pray that we're doing it right. So 7 times 18 is 126. Minus 3 times 26 is negative, what is that? 78. Plus 6. Let's just do that. 126 minus 78 plus 6 is 54. Did you guys get 54? Let me just check the solution because I don't trust myself right now.
Drew got 54.
Drew got, well, if Drew got 54, then.
Yeah.
I do want to bring up my solutions just in case Drew has to go to the bathroom or something.
AKA solution.
Okay, well, let's move on. Here, I got it here. Just get these set here so I can just look at them when I need to. Okay. All right. Next, number 4. Identify any excluded values. Excluded values are zeros in the denominator. So we do need to factor and then simplify the expression. Well, simplify the expression means cancel out any factors or take out any common factors from the top and the bottom. So that's what we have to do. We got to factor these two guys first. First step to factoring is find a GCF, and there is a GCF. There's a -5. I'm going to do -5 because remember, we always want to end up with a positive x squared. So instead of taking out a 5, I'm going to take out a -5. And then I'm left with x squared plus 2x because I'm taking a -5 out of -10. So I have a positive 2x minus 8 because take a -5 out of positive 40 and you get that. It's just a pain in the butt when you have a negative x squared term. So make sure you end up with that. I'm going to take a 4 out of the bottom. So you get x squared plus 11x plus 28. Okay. Now the next step to factoring is look for a difference of 2 squares. There's not a difference of 2 squares, but there is. Step 3 is look for a factorable trinomial, and there is. So I'm going to factor that guy to, what is that? X plus 4, x minus 2. Sorry, my computer's glitchy because it's thinking, so it's making slurred lines. That's what happens when we get old and slow. We slur our lines. Okay, so that's good. Now down here, I can factor this. What 2 numbers multiply to get 28 and add to get 11? 7 and 4. All right, then I'm going to take my red pen and I'm going to lightly kill x plus 4. I'm lightly killing it because I still need to declare the excluded values. So what x will make this factor 0? -4. So I'm going to say x can't equal, or I think it says excluded values. Then you say x equals. So it can't equal -4 and it can't equal -7. Okay. But our simplified answer would be, okay, -5 times. So our simplified answer, I'm going to write it over here, -5 times x minus 2. Ugh. All over 4. And you can just leave it like this. You don't have to multiply it out. X plus 7. Okay. So -4 and -7 are the excluded values. And then you can just leave your answer like this. Just when you're done factoring and canceling, just multiply across, squish it all together and you're done. Okay. All right. If there's no questions, I'm going to move on to number 5. Okay. All right. We're going to graph this sucker. Now this is cool because you can just give me an estimation here. So I'm going to just outline a little bit here. Let's see, I'm going to have to go down. So remember, if it's inside parentheses, if x is being added or subtracted to something before it's squared, then that is a horizontal shift. So this is going to mean shift right. It's the opposite of that sign. Right 3, okay? And then this means it's going to go down 4. So if it's a constant outside of the parentheses, That's going to be down 4. So, and it's not, it is still positive. There's no negative out there. So remember, there's 3 types of shifts. There's flip it over if it's negative, and then shift it horizontally if the x is being added or subtracted to something before it's squared. And then there's a shift vertically, which means just the constant. It's kind of like the, yeah, you're just shifting up or down. Now remember, the opposite, the horizontal shift is opposite of what it says. The vertical shift is exactly what it says. So we're going to go down 4 and then right 3. So this is where our vertex is going to be. And then we're just going to draw just a rough parabola. It doesn't have to be pretty. I just want to see that your vertex is in the right place. Okay. All right. So vertex form. Why does it tell us the vertex form? Okay. I guess that's fine. So does that make sense? Does that feel all right? So remember, this is opposite. So if you want to make a note of this and just put parentheses, this is opposite of what the sign says. All right, let me just check the solution. Looks good. Again, you don't have to make a pretty parabola. You don't have to get exact points. I just want to know where the vertex is and just draw. I just want to see that it's going up and not down. But if there is a negative sign there, remember, it'll be flipped over. Okay. Let me just check the real test to make sure it's not going to throw you for a loop here. Oh yeah, you're fine. You're fine. Okay. So unless there's questions, I'm moving on to number 6. Okay. Number 6, solve this system by graphing. All right. Well, we can graph it if it's, and you can always check it by using substitution or elimination. But graphing means put it in slope-intercept form. So if I can like figure that out, I mean, you guys can do that. You're just getting rid of the x and you're dividing by -2. So this is going to be -1/2 x, and then divide the 3 by -2, and that's -3/2 or -1.5. The reason why I changed this to a mixed number, because that's easier to graph. So on my graph here, that y-intercept of the purple equation is -1.5, so it's about right there. Okay. And then it's a -1/2 slope. Sorry, this is a +1/2, because when I bring the x over there, it's a -x. And then when I divide by -2, it's a +1/2. Did any of you guys catch that? All right. So +1/2 means up 1 over 2. So I'm just going up 1 to this half and over 2, up 1 over 2. Okay, so do you see those? And you don't even have to connect the dots. I'm going to tell you why in a second here. Now I'm going to graph the other equation. So get this y by itself. So that's -2 over 4 or -1/2 x. That is a -1/2 slope. And then 6 divided by 4 is 3/2 or a +1.5. So this +1.5 is right here. -1/2 goes down 1 over 2. Down 1 over 2. So basically where it's crossing is if I connect these dots and connect these dots, see how I'm not doing the whole thing? Where it crosses, if I would have graphed this correctly, is right there. So that is just 3, 0. Let's just check that and make sure it works in both equations. X is 3 and y is 0. So if x is 3, that's 3 minus 0 is 3. If x is 3, it's 6 plus 0 is 6. It works. Okay? So solve by graphing. You need to be able to graph these two equations. You'll get partial credit if you graph it incorrectly, but give me a number. But remember, you shouldn't get this wrong because you can always check your answer in both equations. Okay, if you want to solve by elimination or substitution and forget the graphing because you're totally confused, I'll still give you some credit for doing that. Okay? All right, unless there's questions, I'm moving on to 7. All right, number 7. Multiply, then evaluate. All right, so multiplying these rational expressions means we can cross cancel factors before we multiply. You don't want to just multiply across. You got to factor first. All right, well, we like this. First step of factoring, look for a GCF. There's no GCF, but it is a difference of 2 squares. So I'm going to rewrite that 3x as 3x plus 4, 3x minus 4. Oh, this is terrible. All over x plus 2 times, there is a GCF there. You can take an x out and you're left with x plus 2. Okay. And then to factor this is a tricky one, guys. This is one where I have to trial and error it. Now, the good news is 3x squared. The only thing that it can equal 3x squared is 3x and x. Okay, then you have to start finding factors of 8 that when you FOIL it out, it will combine to 2. All right, so I'm going to try some things. And my bigger one has to be positive. So let's try minus 2 plus 4. Well, when I FOIL that out, I get 3x squared. I already knew that. So I'm looking at 12x and negative 2x. That does not combine to 2. So I'm going to undo that. So let's try, instead of negative, let's try putting the 4 over here. So plus, or let's try putting the 2 over here. No, the negative 2 here. Nope. So negative 4 plus 2. So now when I FOIL it out, I get 6x and negative 4x, which combines to positive 2. All right. So this is going to take some trial and error, but you guys should get it. It's not going to be overly, not going to be more complicated than that, but this is complicated already. So now I'm taking out my red pen and I'm going to cancel, cross cancel factors. The 3x minus 4s can cancel. And the x plus 2s can cancel. You can either cancel this one or you could have canceled vertically there too. So then what you're left with, this whole thing cancels, is a 3x plus 4 all times x on top all over an x plus 2. Okay. Let me just look at the actual test to see if it's crazy. Yeah. So the actual test is going to have another 3x squared. So it's just going to be 3x and x. Then you have to just do some trial and error to get the rest of the way, okay? And then the last part says plug in 3 and evaluate. So just plug in 3 there, and I get 3 times 3 is 9 plus 4. So 9 plus 4 is 13 times 3 all over 5. So that's just 39/5 after you plug in 3. Okay, so that's number 7. That's a tough one, but you guys can do it. I believe in you. All right, number 8 is pretty simple. When you have a negative exponent, that's just, remember, you flip it. So that's just 1 over 4 to the negative, or to the positive 4th. So that's just 1 over 4 times 4 times 4 times 4. So that's 16 times 16, which is 1 over 256. The one on the test is going to be very similar. The one on the test is going to be something to the -5. But here's the deal. The helpful hints that they give you are wrong. So they only give you 4 boxes like they did in the practice test. Okay? But it's something to the -5th, so there should be 5. So there's a typo. So be careful with number 8, okay? Don't go by what it says, just do it, just do the math. So flip it over, multiply 4 times in this case, but it's gonna be, there's gonna be another number to the -5th power. So, all right, you guys clear on number 8? Okay, number 9. All right, so we're going to evaluate for find of -3. So -3 has to satisfy both domains. The domains are real and negative integers, and those are both, those, the -3 satisfies those. So yeah, we're going to plug it into both. And then HG means multiplication. So plug it into H, plug it into G, and then multiply your answers. All right. So H of -3 is, what's the H function? Is x plus 5. So -3 plus 5, which is 2. And then G of -3, the G function is x minus 2. So -3 minus 2. So that's -5. Okay, and then you're going to multiply. So HG of -3 is just 2 times -5. Oh my goodness, stop it. Which is -10. Okay, that's not bad, right? Let me look at the test. Yeah, same thing on the test. You guys are good. All right, number 10. Solve the system of linear equations to determine whether the system is consistent or inconsistent. Okay, so there's many ways you can do this. I'm going to, let's see here. What looks easy here? It looks like the Z's could cancel there. So if I multiply this bottom equation by, or I don't have to multiply, if I just add these two together, then I get 5x plus 12y equals -2, right? And then if I, let's see, if I add these together, I need to get rid of z's in another way. So if I multiply this by 2, so if I multiply this by 2, then I get times 2, sorry. And I get 4x plus 16y plus 6z equals -8. Okay, and now if I add these together, so if I add these two together here, boom, boom, then I get 0x plus 0y equals 0. Well, 0 equals 0. So what does that tell you? You guys remember what that means?
Inconsistent equation.
Inconsistent, that's right. Okay, so, well, let me correct that. It's not a good one, but it is consistent because it's 0 equals 0. If you would have gotten like 5 equals 0, then that would be inconsistent with no solutions. But you have a couple that have the same line, so basically your answer is infinite solutions and consistent. Okay, you see the difference there? If you would have gotten 5 equals 0 instead of 0 equals 0, then that would be inconsistent. But these are dependent equations. Oh my goodness, that's horrible. Why are you scrolling up and down? So this is infinite solutions and consistent. Okay, I guess I want to do cursive. Okay, so I think the test too, let me just take a brief look at the test. It might be a special situation like that, but I don't want to spoil it for you either. But let me look at the solutions here. Let me just say that you are not going to be thrown for a loop, okay? It's not going to be too much different on the test. I won't say more than that. All right, number 11, scrolling down.
Like that, you could tell us that for some of the questions on your test.
Sorry, I can't understand anything you just said. You might have to come closer, or you might, or Mr. Flack can repeat it.
I was saying that your brother should be more like you.
I think you're just being too soft.
Maybe you should be in the middle.
There's a happy medium in there somewhere. All right, so we're going to graph this by solving for y to obtain. Yeah, we know how to do this. We did it in a problem previously. All right, so let's just get y by itself. No problem. No problem. Okay, so first thing we're going to do is throw that 4x over there. So we get negative 2y equals negative 4x plus 8. All right, now divide by negative 2. That is not a z there. It's just stupid computerness. Divide everything by negative 2, and you get y equals positive 2x minus 4, right? Because negative 4 divided by negative 2 is positive 2. 8 divided by negative 2 is negative 4, so that's why it's minus 4. So to graph it, we go down to negative 4 on the y-axis. Then we follow the slope. Well, I don't see rise over run, so let's make that a fraction. If you can't do that in your head, up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Boom, connect the dots like so, and you're done. Not bad, right? Slope intercept is nice. Once you get y by itself, then it reveals all the secrets of the line. Okay. Number 12, change this to feet. You can use a unit multiplier if you want, or you can try to remember back to 2nd grade when you could do this by just dividing by 12. But unit multipliers, write the first label over 1, or change it into a fraction. That's in inches, not in meters. Poopy on you, computer. Times, let's see, 1 foot over 12 inches or 12 inches over 1 foot. Well, you have to pick the unit multiplier that will cancel that first label. That's the whole point. And you're moving towards feet and away from inches. So let's put the inches on the bottom and the feet on the top. So you're dividing 624 basically by 12. What is that? 52?
Yeah.
Okay, so 52 feet and you're done. All right. I don't know how this question got on this test, but you're welcome. All right, find the inverse. Okay, this is the weird one, right? And I don't even remember. I don't know if I remember this, but the determinant is, remember, we swap. We have to, the matrix that we're multiplying this guy by, the determinant of this, well, first of all, find the determinant, okay? So we're going to find the determinant of this, and that is -6 minus 4 is -10, right? And that's what goes down here. So this is 1 over, or -1 over 10. Okay, and then the inverse, we have to swap these. So this -3 goes there, and the 2 goes there. And then instead of swapping the 4 and the 1, instead of swapping the 4 and the 1, we're going to negate the 4 and 1. Okay, and then you just multiply. So -3 times -1/10. Remember, -1/10 is just dividing by -10. So just move the decimal to the left. So -3, and then negative times negative is positive. So move the decimal over 1, and you got 0.3. All right, so now do that with -4. So negative times negative is positive. Move the decimal over 1, and you get 0.4. All right. Move this as negative times a negative is a positive. Move the decimal over 1, you get 0.1. And then negative times a positive. This is our only positive here. So this is a negative. Then move the decimal over 1, and it's 0.2. So -0.2. Let me just make sure that's right. Or if Drew knows, somebody knows. What is that number?
Yeah, that's what I got.
Okay. All right, so a lot to remember. Here's what you need to remember. You need to find the determinant and flip it over. That's what you're multiplying by. Okay, so make a note. You can write that right here. Find the determinant. So that's the determinant. Oh my goodness. The determinant is -10. Oh! That's ridiculous. Okay, and then you got, flip it over, and -1/10. Okay. All right, and then this guy is just, you're changing locations with the 2 and the -3, and instead of changing the locations of 1 and 4, you're just negating them. So it's a lot to remember, but you guys can do it. Make sure you remember that before you take your test. All right, a line with a slope of 8 crosses the y-axis at 0, 6. So the y-intercept is 6. What is the equation of the line written in slope-intercept form? Okay, slope of 8. So that's where the 8 goes, 8 over 1. And then the y-axis intercept is right there. Oh my gosh, how did this guy get on the test? That's nice. Let's just look at the real test and see if it's anything. But then I'm not going to tell you, because Mr. Flack will cry about it and say I'm too soft.
Sorry, didn't mean to hurt your feelings.
You're too soft. I guess we're both a little soft, especially after Thanksgiving. Okay.
Whoa.
All right. Number 15. You guys good with 14? All right, number 15. There are 6 places to sit. Oh, yes. Permutations, combinations. Okay, so here, if there's 6 places to sit, I'm going to put my 6 places here. All right, and use the counting principle. How many different ways can 6 people be seated at the table? There are 6 places to sit at a table, and there's 6 people. So how many choices do you have for the first one? Well, 6. Well, now 1 person is sitting. Now you only have 5 choices. So we're just multiplying down. Now, if for some reason you have 20 people, but there's only 6 places, then instead of starting with 6, you would start with 20, because you have 20 choices for that first chair. You have 19 for the second, but there's 6 places, okay? We're gonna do more of these combinations and permutations a little bit later, but this is the basic counting principle. When you multiply that all out, you get 720. Okay, where am I? 720. All right, so far so good. You guys feel all right with that? It's going to be very similar, shamelessly similar. I'm going to change the settings on my tablet here. 1 second here. Disabled. Disable.
Why the test questions are just like the notes. Might make you want to take notes.
The what?
Said if the test questions are just like the notes, you might make you want to even take notes in class.
Yeah.
Oh, there's the video.
Unless you're a moron. I mean,
So these
morons-
days they just save it for the video, I guess.
Yeah, that's right. Kids these days with their technology.
You can go learn it
Okay.
on your own time.
I think I wrote that in the wrong place. Sorry. Jeez. That should be at right there, number 15. Number 16, subtract. So just combine like terms, but beware of this subtracting a parenthesis thing. Okay, 6x cubed minus 2x cubed is 4x cubed. Okay, negative 2x squared minus minus. So if it helps, do this. Plus, but instead of putting a negative there, you're going to distribute that negative everywhere. So you can do that. Maybe that's more confusing. Either way, you could always plug in a number for x and then try to solve it both ways and see if you get the same answer. Check your work. All right, so the x squared is combined to a negative 2x squared and a positive x squared. So that's a negative x squared. All right, and then you're just left with this lingering -8 or -8. Okay. If you're going to mess this up, it's going to be right here. So be careful with that. Distribute that negative and ignore the parentheses, or just keep in mind that you're subtracting everything in here. So if you're subtracting, you're adding that x squared. Okay. Cramer's rule, you can use Cramer's rule if you want. I'm gonna use Cramer's rule. Or you can solve by substitution, or elimination would be easier by just negating the bottom one, adding them, and you're home free. But I'm gonna use Cramer's rule because that's what the cool kids are doing, and I kind of need practice anyway. I'm gonna zoom in a little bit. So Cramer's rule is X is this matrix where you're reversing the 9 and 7. So you're putting the 9 and 7 here, and then the 4 and 2 over here. And then this bottom is the same for y as it is x. It's just the coefficient matrix, the coefficient of x and y. So this is 5 and 5 and 4 and 2. It's the same for both. 5 and 5, 4 and 2. All right, and then this top matrix is how it's written. So 5 and 5 and 9 and 7. So 5 and 5 and 9 and 7. For some reason with the x, when you're finding the x, you put the constants on the left side. Okay, so let's determine the determinants of those guys. So this is 18 minus 28. So that's -10 all over this guy, which is 10 minus 20, which is -10. So x equals 1. All right, this guy's going to be 45 minus 45, which is 0 over whatever. So y is going to be 0. Let's just check it, make sure it's right. So 5 plus 0 is not right. So let's see what we did wrong here. 18 minus 28, -28. 10 minus 20, -10. Okay, so 5 and 9. Oh, 9. This should be a 7 there. Sorry. guess we're deleting the whole thing. Sorry about that. So this is a 5 and 5 and a 9 and 7. So that's 35 minus 45, which is negative 10. Negative 10 divided by negative 10 is also 1. So let's see, 5 plus 4 is 9, 5 plus 2 is 7. That works. Okay. If you use Cramer's rule, you're cool, but you don't have to, all right? If you want to use elimination method or substitution, you can, okay? All right, number 18. Graph and state the domain of the function. So we're just going to graph these, just plot those stinking points. So let's put a graph here. Negative 5, 4 is right there. Negative 2, 2 is right there. 1, 0 is right there. 4, negative 2 is right there. Don't connect the dots. Don't do it. I know it's tempted because it makes a straight line, but don't connect them. This is a discrete function, okay? Because it's just these 4 things. So the domain is the x values and the range is the y values. So negative 5, negative 2, 1, and 4. And then you got 4, 2. It's better to go in order, but it's okay. Does that make sense? You guys good with that? You've done like 2 or 3 of these on tests already, so you should be good with that. All right, number 19, solve by substitution. All right, that's nice. So I'm gonna do this. Since y is almost by itself, y actually, you put that negative 5x over there and it's 5x plus 3. So this is what we're plugging in to that y right there. So that's what I'm gonna do. 4 times 5x plus 3. Ugh. 5x plus 3 minus 6x equals negative 16. Multiply that out, 20x, and then you end up with 14x. So 12 plus 12 equals negative 16. Put that 12 over there, and so you get 14x equals negative 28. So x equals negative 2. I don't know why I circled that. So x equals negative 2. So that's what we're going to plug in right there. So if x equals negative 2, y equals negative 10 plus 3, which is negative 7. Let's just make sure that's right. Negative 7 plus positive 10 is positive 3. Then we already know this is right. So negative 8 plus 12 is not that, right? Did I do something wrong? Negative 8, no. So negative 28 plus positive 12. All right, negative 16, that works. Okay, solve by substitution. Just get y, get one of the variables by itself and plug it into the other equation, okay? All right, we got one more. Sorry to go quick. Write this in standard form. Oh, no problem. Just write it in descending order. And for some reason, they put the negative over here. Why? So all you're doing is moving all this stuff over here. I don't know why they did it that way. Standard form is nice when the x squared term is negative. So when you pull it over there, you get negative 7x squared. Oh, wait, what's happening? Oh, okay, let's just bring it. Yeah, that's dumb. Okay, so we're writing it, we're getting y by itself. Let's just do that. So when you get y by itself, y will be left on the right side. And then that 7x squared is the only one that goes over. So negative 7x squared plus 3x plus 4. Standard form is descending order of exponents of the variables, and just everything on one side. So that's it for number 20.
Black math, give me some math and I'll give you some flack. Black math.